Ever held like an emerald in your hand?
Mm.
Or like watched a spacecraft blast off?
Yeah.
It's wild. But you were looking at beryllium in action.
Wow.
And that's what we're doing today. A deep dive on beryllium.
I love it.
We're going to go like everywhere with this, from the periodic table to supernovas, all that good stuff.
You've got a really cool mix of sources for this. We'll be able to look at beryllium in all kinds of ways, like from its atoms to what it can build, the whole picture.
So first things first, periodic table. Where do we even find beryllium? What's its like elemental ID number?
Okay, beryllium is number 4 on the periodic table.
Number 4, okay.
And that little number, it tells us a lot. That's one of the first things we learned from that beryllium element information properties and use.
Periodic table source you shared?
So what's it tell us? Well, for one, it's a real lightweight. Only 4 protons in its nucleus.
Okay.
It's a metal, silvery white, but way less dense than you'd think for how strong it is.
So like imagine a feather,
Yeah.
but it's somehow stronger than steel.
Yeah.
That's beryllium.
Exactly. And to add to that, it melts at 2,349 degrees Fahrenheit.
Oh, wow.
That's hotter than a lot of volcanoes.
No backyard smelting for this one.
Right.
Why is the melting point so important anyway?
Because it shows just how much beryllium can do, that strength, that lightness. Perfect for aerospace stuff. But actually working with it, that takes serious tech because it can handle such extreme heat.
Makes sense. You know, something I saw in that Wikipedia article really surprised me. Beryllium, it's rare, right? And it comes from supernovas. Like, how does that even work?
It's a pretty epic journey to get from a supernova to our planet, honestly. Most of the beryllium we have, it was made billions of years ago when a star died. A massive star.
We're talking supernova explosions.
Yeah, exactly.
Wow. Hold on. So the beryllium in my phone, that little bit, it came from a supernova.
Pretty much. It puts things in perspective, right?
It really does.
And speaking of rare things, back in 2001, beryllium cost $338 per pound.
Seriously. That's more than some cars.
No kidding. Now, on Earth, we find beryllium in over 100 different minerals, but the most famous one gotta be beryl.
Emeralds, aquamarines.
Yeah, it's like beryllium's hiding out in the Earth, and those gemstones, that's its best disguise.
I love that.
Those colors. Tiny bits of other elements, but at the heart of it, it's all beryllium just putting on a show.
Okay, so we've got this like super rare element, crazy strong, comes from exploding stars, hides in jewelry. But what do we actually use it for?
You know, it's funny, all those wild properties we talked about, that strength, lightness, the way it handles heat, they make it useful for some really cool stuff.
Like what? Hit me with it.
Okay, how about X-rays? I bet you've seen those before.
Sure.
Remember how beryllium has that low atomic number?
Yeah, number 4, right, on the periodic table.
Exactly. And that basically means X-rays can just pass right through it, like a window, but for these powerful rays.
Okay, so in like a doctor's office, what's beryllium actually doing?
So you're getting an X-ray, right? Beryllium's often in the window of that machine. It lets the X-rays through, but blocks other radiation that would be bad for us.
So it's a shield and a window at the same time.
Exactly. And because it's so strong, so good with heat, it's fine even with those intense X-rays hitting it.
Smart. Makes sense this stuff is in high demand.
Oh, yeah. And it goes way beyond medicine, too. Aerospace engineering uses a ton of beryllium. Remember the whole feather stronger than steel thing?
Oh, yeah.
That makes it perfect for anything going to space, rockets, spacecraft parts, even those heat shields to protect them when they come back through the atmosphere.
So those amazing launches we see, beryllium could be part of that.
A lot of times it is. It's like a secret ingredient for space exploration. And this one might surprise you. Some really fancy speakers use beryllium, too.
No way. Seriously, what does it do for sound?
It's that stiffness and being lightweight makes the speaker diaphragm super responsive, so the sound is crystal clear.
I thought this was some niche element, but it's in my X-rays, spacecraft, even my music.
It's more common than you think, even if we don't realize it. But with all that awesome stuff, there's a flip side with beryllium. Gotta be honest.
You mean the toxicity we mentioned earlier?
Yeah, exactly. And that's something we need to talk about.
So we've talked about all this amazing stuff beryllium can do. X-rays, spacecraft, even our music. But there's that health risk too, right? Toxicity. What's the deal with that?
Yeah, so beryllium on its own, it's not really dangerous. But if it's like a fine dust, that's where it gets serious, especially in industrial settings, you know.
What happens if someone breathes in that dust?
It can cause this lung disease, berylliosis, and the thing is, it might not even show up for years, decades even.
So you could be exposed and not know it for years. That's scary.
Yeah, it's a real concern. That's why that beryllium element information, properties, and use
Its
it.
periodic table source was so big on the safety stuff. Ventilation's got to be good, protective gear, regular checkups. That's crucial for anyone working with beryllium.
This is serious stuff. It makes you wonder, how do we balance the good, all the amazing things beryllium does, with that risk? It's a tough one.
It really is. And it's something people are thinking about a lot. Scientists, engineers, policymakers, you name it. Because on one hand, yeah, we need this element. Medical imaging, space exploration, even renewable energy, it's all using beryllium. But then there's the other side, keeping people safe, making sure we're not doing more harm than good, you know.
So it's not even just about the science itself, it's how we use it, right?
Right.
Ethically, I mean. 100%. And that takes being informed. When we know the good and the bad about beryllium, then we can start asking those tougher questions. How do we minimize exposure? Are there other materials that could work? How do we share the benefits, not just keep them for a few?
Man, those are some big questions. It's like beryllium, this one element, it's a tiny example of a much bigger conversation about technology, progress, our responsibility for all of it.
Absolutely, you nailed it. And that's what I love about these deep dives, honestly. We start with something that seems simple, just an element on the periodic table, but it takes us to these huge questions about innovation, ethics, even the future of the planet.
I've learned so much today. It's kind of crazy. I'm never going to look at an emerald the same way again. Or an X-ray. Even my speakers.
Right. It's amazing what's hidden in plain sight.
Totally. Well, thanks for taking us on this journey. It's been fantastic.
Happy to do it. Always fun to dive deep into this stuff.